This ShowMe is an extension of my previous work with the FOIL method, so if you haven't taken a look at the ShowMe I've done already about multiplying binomials, you might want to start there, because I'm going to assume that the people that are viewing this ShowMe have that knowledge already. Here we're going to focus on two particular patterns that emerge when you use the FOIL method. The first pattern deals with the square of a binomial, and the second one deals with multiplying two related binomials, the sum of two terms times the difference of the same two terms. Let's kind of review the geometric interpretation of this process as we look at the process of squaring a binomial. I got a plus b quantity squared, which is going to be a plus b times a plus b. Well, that creates the perfect rectangle model, where we have length times width representing the area of a rectangle. Here we have the Poliquin art representation of the square in question. Its length is a plus b, and its width is a plus b. Of course, to find the area of the entire square, we can break it up into the four regions I've shown here. The upper left region is square. Length and width are both a. A times a is a squared, so the area of that region is a squared. To the right of that, we've got a rectangle. The length of the rectangle is b, the width of it is a, so its area is their product, which I'm going to call AB. In the same fashion, the lower left corner is a rectangle. Its length is a, its width is b, its area is AB. And finally, the bottom right corner is a square. Length and width are both b, so its area is b squared. So, from here we have a squared plus ab plus ab again plus b squared. That's equivalent to the product of those two binomials. Finally then, combining the like terms in the middle, we have a squared plus 2ab plus b squared. The first time students ever look at this, particularly those who haven't paid close attention to the FOIL method, they are usually convinced that the quantity a plus b squared should be equal to a squared plus b squared. But obviously the geometric model blows that out of the water. If you just have a squared and b squared, you haven't got the entire rectangle covered. You're leaving two important parts of the entire figure out of the picture completely. That's not right. So this answer is incorrect. Be very careful not to fall into that trap. It's so easy to do. But the square of a binomial, a plus b quantity squared, is a squared plus 2ab plus b squared. That pattern will always emerge from squares. That makes it extremely important, both in calculating the squares, if you choose to do it this way, or in factoring them, which is definitely going to be an important part of your work as you learn more about binomials, polynomials, and factoring. Now we need to consider what happens if our sum is actually a difference. Well, first of all, it's important to remember that every difference you ever saw can also be written as a sum. All you have to do is think of the numbers as rational or real numbers, and then subtraction is actually adding the opposite of the second number. So a minus b is really taking a plus negative b. You're going to get the same result either way, but modeling it this way, we can use the rule we just developed to find an answer for this product. So a is still going to be positive. A squared is still going to be a squared. That's not going to change. In a difference, however, the b term, the second term, is negative. So 2ab is not going to be positive anymore, because you're going to have 2 times a, which we presume to be positive, or at least to not have a negative sign in front of it. But we know that b does now have a negative sign in front of it. So that middle term is going to change signs. It's going to be minus 2ab. Interestingly, at the very end, we're still going to have a plus b squared. The reason for that is if you take the opposite of b and square it, you're going to take a negative times a negative, which is a positive. My students remember wrestling with the implications of having the parentheses and not having them in the unit about exponents. This is one of the important places where that comes into play. So, when you have a difference and you're squaring it, the only real change is that the middle term is negative. Other than that, the result looks very much like the product when you have a square of a sum in binomial form. So these two expressions, whenever you see this pattern, anytime you encounter it, you're dealing with a square. And if you have to square a sum or a difference, this pattern in the result is consistent. It'll always happen. That means that you could memorize this pattern and use it to quickly execute squaring, as opposed to going through the process of the FOIL method. It doesn't matter which way you do it. It's important that you get it right. So if you're going to memorize this, commit to that and practice it that way throughout the assignment. If you want to continue using the FOIL method, great. That will get you the right answer every time. One thing to be careful about is that if you use the FOIL method, you may not memorize this pattern. And when you're working backwards, this is a useful pattern to recognize. It's also going to be a fundamental pattern, and one of the most important things you're going to do this year in your introductory algebra courses, which is to derive the general solution of quadratic equations. This is part of that process. In any rate, you need to pick a method, either this or the FOIL method, and stick to it. And I'm going to show you some examples done both ways so that you can choose and make a good decision for yourself. So here we have the quantity x plus 6 squared. Let's say we're going to use our new information. Well, if you're going to use a rule, I recommend that you should write it. And the rule we're going to use is that the quantity a plus b squared is equal to a squared plus 2ab plus b squared. All we have to do now is decide which one's a, which one's b, and plug them in. Well, I think that x is a, so the first term is going to be x squared. I also think that 6 is b, so then I have 2 times x times 6. And since b is 6, the last term is going to be 36. Final answer then, x squared plus 12x plus 36. Cut and dried and simple. The only catch is you have to memorize this pattern if you're going to do it this way. I think it's worth your time to memorize that pattern, but you do have another method at your disposal that will definitely get you the right answer every time, as long as you've practiced it. And that is to rewrite this product as x plus 6 times x plus 6, and employ our old friend, the FOIL method. First terms, their product is x squared. Outside terms, the product is 6x. Inside terms, the product is also 6x. Then last term, 6 times 6 is 36. Note, this is the reason there's a 2 here in the middle, is that the outside and inside terms are duplicates. And that's why in the pattern to be memorized on the other side of the screen, you have a 2 there. Everything was positive. We're adding all the way. Combining your like terms in the middle, which is often required with the FOIL method, you end up with x squared plus 12x plus 36. So you can see in the final analysis, if we're just going to evaluate things based on getting the right answer, it doesn't matter which method you use. However, there's more to this than the final analysis. I want to remind you, you're going to have to learn to do this backward at some point during the unit. And when that happens, this pattern is going to be something that you need to have memorized. So committing that to memory is still something I think is important. Having said that, if you're obsessed with getting the right answer and you haven't got time to memorize, or maybe you're not good at memorizing, then FOIL method may be the way to go. Let's practice this on a difference as well, just to make sure that we understand. Let's say we're going to use our pattern. The pattern for a difference is a squared minus 2ab plus b squared. The only difference between the difference and the sum is that minus sign in front of the 2 in the middle term. Okay, I think a is going to be 5x. So 5x squared goes here. And I think that b is going to be 2. Notice that b isn't negative 2. This isn't the sum we're dealing with. There's a minus in the formula, so our minus in the original statement doesn't need to be accounted for in our variable assignments. So we have 5x quantity squared minus 2 times 5x times 2. And then b is 2, so we have plus 2 squared. Well, the quantity 5x squared is 25x squared. 2 times 5x times 2 is 20x, and of course it's still negative. And then 2 squared is 4. So this is the square of that expression. Again, I think this is an important pattern to memorize. You're going to have to use it whenever you learn to factor these. So it's not something you can just gloss over and say, well, the flow method will get me there. Maybe, maybe not. I really think it's a good idea to go ahead and memorize this pattern as well, because it's something to watch for. It'll speed up some of your factoring down the road. That said, if you really want to use the flow method here, it's going to work. Of course, whenever you use it, you should write your letters out. First times first, 25x squared. Outside, 5x times negative 2 is negative 10x. Inside, negative 2 times 5x is negative 10x. And last, negative 2 times negative 2, positive 4. So we have 25x squared minus 20x plus 4. Again, the final analysis, if the answer is all you're worried about, it doesn't matter which way you do it. If you want to make your future a little bit easier as you learn to factor things, I think memorizing this pattern is a good idea. There's another special case that we're going to address here. It's the product of a sum and of a difference of the same numbers. A situation that actually comes up fairly frequently as we make progress through the topic in math and then in the applications as well. Well, let's use the flow method to figure out what's going to happen here. Flow method says we have first, outside, inside, last. The first terms, the product of the first terms, a times a is a squared. Outside terms, a times negative b is negative ab. The inside terms, b times a, ab, positive. And last times last, b times negative b is negative b squared. As usually is the case with the flow method, the two terms in the middle are like terms, can be added together. The tricky thing about these is that those middle terms cancel out. They simply disappear from the problem. Negative AB and AB are opposites. They add up to 0. So the result of this product is always going to be a squared minus b squared. We're going to exploit that for a number of purposes, and here I'm going to give up one of my little secrets. One of my favorite things to do throughout the year, the early parts of the year, is to show off my ability to multiply large numbers in my head. How do I do that? I use this rule. Let me show you how I do it. Let's say that we had 31 times 29. For me, that's a pretty easy multiply. Here's why. 30 can be rewritten as 30 plus 1. 29 can also be rewritten as 30 minus 1. That brings this pattern into play because that's the pattern. A would be 30, B would be 1. Well, it just so happens that I took the time, math nerd that I am, to memorize squares all the way up to 30. So I know that 30 squared is 900. And I know that 1 squared is 1. You probably knew that too. And 900 minus 1 is 899. The product of 31 and 29 is 899. And it's that quick, it's that easy. It's much faster than doing the 2-line multiplication. Although, in case you're wondering, I've mastered that too for 2-digit numbers in my head. But this is the technique I use. So now one of my secrets is out. Let's do that one more time, just to make sure you've got it. Here we have 52 times 48. 50 can be rewritten as 50 plus 2. And 48 can be rewritten as 50 minus 2. And now we can use our rule. That's going to be 50 squared minus 4, or minus 2 squared to be consistent, I suppose is what I should write there. Well, 50 squared is 2,500. And 2 squared is 4, so the product is 2,496. The trick to this, of course, is that whenever you see two numbers like this, you have to decide quickly, can I rewrite them this way? Well, it's very simple. If their difference is even, then you can. So here, the first thing I would look at to decide whether I was going to use this technique to show off for my class or whatever I'm doing is to take 52 minus 48 and see if it's an even number. If it is, then this is something that we can do. Once you know it's an even number, an even difference, the next thing is, what's the average of the two numbers? What number is right in the middle? Well, whatever number that is going to be A. So, first of all, do they have an even difference? And once you've determined that that's the case, this is the number in the middle, and this is the distance from that middle number to each of the two numbers. I say each, I guess you say difference, but it's the same idea. So once I know that they have an even difference, I find the number in the middle, how far is it from that number to the two numbers, and I have A and B. And if you've memorized a few numbers, this is a pretty easy process. Anyway, there's some exercises like this for my students to do, and I need to give away the entire secret if they're going to get through them without banging their heads against a few walls. So there you go, kids. That's how I pulled it off. This particular pattern is so important, I really advise you not to use the FOIL method, because it's such an easy pattern to use. You have x plus 9 times x minus 9. As soon as you see a sum and difference of the same two numbers, you know you're going to use your pattern. We're going to use a plus b times a minus b equals a squared minus b squared. As before, when you employ patterns like this, all you really have to do is determine what a and b are, and you're in business. Well, a is x, b is 9. So I've got x squared minus 9 squared, which is x squared minus 81. Done. That's it. That's the product of x plus 9 and x minus 9. But if you really want to hold on to that FOIL method, it will still serve you well if all you're concerned about is getting the answer. First times first, x times x is x squared. Outside times outside. X times negative 9 is negative 9x. Inside times inside, 9 times x is 9x. And last times last, 9 times negative 9 is negative 81. As before, the two middle terms are like terms, and as before, they cancel each other out. So your answer is x squared minus 81. I just think there's a lot of work going on in there that doesn't need to be done. I really think that it's a good idea. Even if you weren't going to memorize the other patterns, I think it's a really good idea to memorize this one. It's going to come up in quite a few places, and it'll really simplify the process if you have a lot of complicated factoring problems to do. My students do, and I suspect that you will as well. So those are the two special cases that I'm dealing with in this ShowMe. We know how to square things, and we know how to find the product of a sum and difference of the same number. For the sake of preparing you for some of the more complicated factoring problems that will probably show up later in the unit on polynomials and factoring, let's do one involving a higher degree binomial. The process remains the same. If you're going to use the pattern, then a plus b times a minus b is a squared minus b squared. Well, in this case, a is x squared. X squared squared is going to be the first term in our product. And then 5 squared is going to be the second term. X squared squared, multiply the exponents, you get x to the 4th. And 5 squared is 25. That's done. If you're going to use the FOIL method, that'll work too. The product of the first terms is x squared times x squared, which is x to the 4th. Product of the outside terms is x squared times negative 5, which is negative 5x squared. The inside terms, 5 times x squared is plus 5x squared. And the last term is 5 times negative 5, which is negative 25. Again, we have like terms in the middle, and again they cancel each other out. So the answer is x to the 4th minus 25. I hope that clarifies the method for you. Going forward, in all of these cases, I am not going to use the FOIL method for squaring things. I'm not going to use the FOIL method for multiplying sums and differences of the same terms. I'm going to use the patterns and model that for you. So in later ShowMes, when these things pop up, and they will, you're not going to see the FOIL method being done for these. That's okay. If you choose to use the FOIL method, just remember, that's your business. I've advised you to learn these patterns. I think it'll help you to do that, and I strongly recommend